All right, our first analysis that we're going to cover here is correlations. So what types of questions are we asking with correlations? Now, first, I want you to remember that correlations, we need to have two continuous or ordinal variables. That's the foundation of how this analysis works. So we're asking how those two variables are associated with each other. So for example, we might ask, how is social media use linked to depression? How is family size linked to intelligence? How is, my hours of sleep I get before the night of a test correlated with my score on that test? So we're seeing how these two things kind of work together or go together. Um, uh, Graphically, what we're talking about here is a linear slope between two variables. In fact, the correlation coefficient is a slope itself. Um, so Here's some examples. If we have a correlation of 0.8, it's going to look graphically like this. As one variable goes up, the other variable goes up. Also, as one variable goes down, the other one goes down. So let's say this is social media use on our x-axis. Let's say it's depression on our y-axis. We'd be saying that as people use social media more, they are more depressed. But we could also say it the opposite way. As they use social media less, they are less depressed. A correlation of 0.2 would be a weaker connection, but it would still be showing the same thing, right? More social media use, more depression, or less social media use, less depression. The key thing there is that we're talking about the variables going in the same direction. As one goes up, the other one goes up. As one goes down, the other one goes down. Now, you know the old adage, correlation does not determine or prove causation. Um, I could talk in class about some nitpicking that argument because there's a little more to it than that. But that is true in this case, right? It's important to keep in mind that we're not saying this one causes that one, just they correlate or associate together. A correlation of 0 would mean there's no connection between these two. So again, if it's social media use and depression, we're saying more social media use doesn't matter. Like it's just not connected to your depressive symptoms at all. If it's a negative correlation, it's going to look something like this. So let's stick with the social media use here. We'd be saying more social media use, fewer depressive symptoms, or less depression. The opposite would be true too, or true, right? So less social media use, more depression. And then a stronger negative correlation would look something like that. So again, it's a linear association between these two things, not a causal relationship, but a linear thing, and that these things are kind of going together. If it's positive, they go in the same direction. If it's negative, as one goes up, the other one goes down. So again, keep in mind, it's two continuous or ordinal variables that we're looking at. So we're going to use a package here called APA. The APA package technically doesn't actually run the correlation. It actually just it tidies up the correlation for us and gives the output in a much nicer format that's easier to use. So you've got two options on your code here. You can do APA, and then in parentheses, you're going to do core.test, and then formula equals, and you can just list the variables, variable 1 and variable 2, and then specify your data frame, or you can do x equals and do your variable data frame name, money symbol variable name, and then y equals, same thing for your second variable. And it's going to print out something like this in your console. So R here actually stands for correlation. In statistics, R is the standard letter that refers to correlation. Unfortunately, the software R is not referring to correlation. I always thought it was, but it turns out the guys who made it were named like Robert and Ron or something like that. Both of their names started with R. Um, but again, R here stands for correlation. This is something called the degrees of freedom. We're not going to dive into how those are calculated and how they're used in the models. But here just to say that it's a reflection of your sample size. So whatever your sample size is, minus 2 is what this number is. Or if you add 2 to that number, that's your sample size. This number right here actually is the correlation, so it's that slope or that correlation coefficient. This letter here saying here's your p-value, and in this case it's a small enough one, they're saying it's less than 0.001. So remember, this is the probability that that null hypothesis is true given the data that we have. So here we would be saying it's less than a 0.1% chance that there is no correlation between these two things. All right, let's jump over to Learning Suite for a second, and let's do Learning Suite, RStudio, and do an example together. So I've got a data set here. I think it is actually the same data set that you can use for the Mary Lou Fulton conference. And we've got a number of variables here. Do I have the code book readily available? Yes, I do. All right, let's pull up this code book. All right, so again, the whole point here is we're asking questions. We're trying to learn things. We want to understand how people develop and how families work. And we've cleaned all this data. Now we've got it. Let's go ahead and use it. So I'm really interested in things about sibling relationships. And maybe I'm interested in sibling social comparison and also contact with your sibling. So let's go look at those. Okay, so contact with sibling. We've got this variable here. How frequently do you have any sort of contact with your sibling? And it originally was it scored 1 to 9, so 1 is never, 9 is daily. It's kind of weird to have this backwards like this, but higher values mean more contact, so that's handy. And I want to know, if you have more contact with your sibling, are you going to compare yourself to them more? Let's find that comparison variable. Okay, so then we have the sibcomp variable here, which is also an ordinal variable. And higher values here mean you're going to compare yourself more to your sibling. And I want to know, right, is there anything to that? If I have more contact with my sibling, am I going to compare myself to them more? Question. If I have more contact with my sibling, and these are all adult siblings, do I compare myself to them? Now, the way I've phrased this, right, it sounds causal. Like I have contact, therefore I'm going to have more comparison with my sibling. But the truth is, it's cross-sectional study, and we don't actually know which one would cause the other. That's okay. I'm going to do it this version. Got the data frame. Let's jump back to that code book. Contact sib1. Contact sib1. This one was just any type of contact. We also have other types of contact. And then this one was sibcomp. Okay, so let's run that. Of course, it couldn't find the function APA. I didn't activate my packages up here. Now you'll need to install the package first. I already have it installed. Okay. So what we've got down here in the console is our output. So R is just reminding us this is a correlation. My sample size is going to be 489 plus 2. In fact, I can see that up there. 491 is my sample size. The correlation is 0.15, and the p-value is less than 0.001. typically I'm going to start here with a p-value. And if the p-value is not significant, that's the same as saying these two things are not connected, right? Or I'm going to go with that null hypothesis and say there's no correlation here, there's no association. But the p-value here is less than 0.001, so I'm saying there's less than a 0.1% chance that, given the data that I have, there's less than a 0.1% chance that these two things are not connected to each other at all. Another way to say that is there's less than a 1 in a 1,000 chance that there's no connection between contact with your sibling and social comparison with them. So what we have here is a positive association. So we're saying that as one goes up, the other one goes up. Also, as one goes down, the other one goes down. So that would say that as I have more contact with my sibling, I compare myself to them more. That makes sense. So, right, more comparison, or more contact, more comparison. Now, this is not a very strong correlation, right? That slope is not very steep, but it is significant. A key point here that I will harp on, especially when we get to regression, is that the p-value is not a measure of how big this number is. It's a measure of how confident we are in that number. And in this case, we're very confident. Let's pick out another one. I want to find something that I think will be like a negative association. So we also have in here like support that you receive from your sibling, and you have depressive symptoms. Let's look at those. So maybe I think if you get more support from your sibling, you're going to have fewer depressive symptoms. Now, depression, depressive symptoms here is an ordinal variable. It's on a 1 to 5 scale. And we've already got this scale created, this depth variable. So let's jump back to RStudio. I'm going to copy and paste this. If I receive more support from my sibling, am I less depressed? Okay, so I'm going to change my y variable to depth. Fix my spelling there, and let's see about the support. Contact, support provided to sibling, support received from sibling. Okay. So one of these might be, okay. So this one is like an average of all of the support questions. So it's like emotional, financial, help around the house, those kind of things. Why don't we go with the emotional support? So it's sup_re6. Again, a nominal variable here, or ordinal, sorry, where higher values mean more support. I'm going to copy that. Let's paste it over here. So both of these variables are ordinal, so it's appropriate for a correlation. Oh, this is good. Okay. So, like I said, I'm actually typically going to start here at the p-value. So the p-value here is greater than 0.05. So we're going to say this is not statistically significant. And instead, say we're going to support the null hypothesis. There is no correlation, there is no connection between receiving emotional support from your sibling and your depressive symptoms. The p-value being 0.453, we're saying there's a 45.3% chance that, given the data we have here, there is just no connection between these two things. So, right, we're not 100% sure, but that's a high enough number that we're not going to risk it and say we trust this. Now the correlation is negative, but in this case, because it's not significant, it just doesn't matter. Now I'm really curious. So that's the support you receive from your sibling. if I give, what if you give more support to your sibling? Let's take, it's that same variable, but instead of sup_re, it's sup_pr. Let's try that. Nope, that one's not connected either, right? P-value 0.345. So because it's greater than 0.05, we're saying there is no connection between these two things. At least not one that we're confident in. We're not going to trust it. Let's say the p-value was less than 0.05. How would we interpret this negative correlation? We would say that as support goes up, depressive symptoms go down. Okay, so there's some good examples of running bivariate correlations. Now, occasionally, we went through that already, occasionally you need to create, or you want to run correlations on a whole bunch of variables because you need to submit a correlation table. It's fairly common, excuse me, excuse me, fairly common in published studies. In fact, you'll see this in a lot of the replication project articles, where in there somewhere they have just this correlation table. And it's simply just a bunch of those bivariate correlations in a table. So you've got like all the main study variables and how they're all correlated with each other. Let's say I've got 20 variables. I could go through and run this however many different combinations there are going to be amongst those 20 variables. I'm not good at that kind of math off the top of my head, but I'm going to have to run this a bunch of times over and over and over. So there are other packages and functions that are going to help us instead run correlations on a bunch of variables at the same time and give us the information we need just to save us coding. So the way we're going to do that, we're going to use this package called HMISC, and I'm drawing a blank, I can't remember what that stands for. So install it and activate it, and then you're going to create a little subset of just the variables that you want correlations of. You know how to do this, right? You can specify the column numbers, or you can specify the variable names, which I prefer. And then you're going to use this code down here, rcore, and then nested in that as dot matrix and the name of that subset. And it's going to spit out something like this. So in the top half here will be the correlations between each combination of variables. So here, if you've got 5 variables, or 4 variables, 1, 2, 3, 4, 5, you're going to end up having these 6 different correlations. So right here would be the correlation between con1 and con2. Now it looks a little messy because the diagonal here is the correlation between itself. So all those ones are going to be 1. And then we say this is like below the diagonal and above the diagonal. Above the diagonal is just a mirror of the information below the diagonal. So right here would be the correlation also between con1 and con2. And the points, or the information down here, it's giving you the p-values. So this would be the p-value for the correlation between con1 and con2. And we'd say those two things are not correlated with each other. We're going to support the null hypothesis because it's 0.4655 is our p-value. So we're saying there's like about a 47% chance that there's no connection between these two things. Lastly, in this information, it's going to give you your sample size right there. Let's jump back to RStudio and do this together. Now, typically, these types of correlations, you're not running these because you have some questions like you did with this. It's, I need to create this table for a paper, and so I need to just get a bunch of correlations at the same time. Again, it's this HMISC package. Make sure you install that and activate it. And then in this case, let's get, what if we want, that the support question, I thought was so interesting. I want all the support questions, and I want anxiety and depression, and I want to know if there are any correlations amongst all those. So we're going to create a little subset of the data. It's going to be from the data frame. We're going to take certain variables. So I ran names so that I could just copy and paste all of those. I want to find where's the depression variables. There's one called DEP. There's one called anxiety. Yeah, we'll just take the depression one. So in the first half of the semester, what I had you do was create an object, was the name of these variables, and then you're putting that object name into your brackets here. I'm doing it a slightly different way here just to save me a line of code, but again, you know how to create those little data subsets already, so we're not necessarily teaching you that. And I'm just a little OCD sometimes, getting rid of all those spaces. Okay. So I've got this data frame subset. It's got these 15 variables. So if I was going to run correlations to get every variable correlated with every other variable, I'm going to have to run that other code a bunch of times. This is going to just make it that much faster. So the function then is rcore. You do as.matrix. The as.matrix part saves it in that kind of, or prints it out in that table format that we saw in PowerPoint. This is going to be a little bit messier because I have 15 variables. But now I can look through this table here and I can see how is depression correlated with these other variables. And I mean, those correlations are small. How it's correlated with, it's like this is the correlation between depression and the support provided, the third one. This is the correlation between depression and support received, the second one. All right, so it just looks like those things are not correlated with each other. We can look at the p-values to check, and all of these p-values are greater than 0.5. Oh, except, okay, let's come up here. Okay, the correlation between support received to the 7th variable and your depressive symptoms was positive. And here's its p-value. I know this is messy. SupRe7 and depressive symptoms, its p-value is 0.0443. So we're saying there's a 4.43% chance that these things are not connected, given the data we have. What was the 7th variable? Oh, interesting. It's being given money, financial things by your sibling. So that being and so this is the p-value. Going to come back up here. This is the correlation. Again, depression and SupRe7. It's 0.09, so it's positive. So it's saying if I receive more support from my sibling, I'm more depressed, right? Or it could be the other way around. The more depressed I am, the more support I receive. That's really cool. Okay, in the next video, we will talk about introducing t-test and also the assumptions of t-test.